Hey guys, well I've decided to start chemistry past papers and today we're going to be doing paper 2H from November 2007 for chemistry. First of all, it's my first time doing a chemistry paper, so if it's a bit bad with the tutorials, don't bother, ask questions in the comment section below. I might not be that good at explaining, but over time hopefully I'll get good. Alright, question 1 has given you the structures of 6 hydrocarbons in diagrams, and this is shown here. And the first question, question 1A1, is asking you to give the letter of a hydrocarbon which is not an alkene. Now first of all, an alkene, what is it? An alkene is a sort of hydrocarbon. A hydrocarbon is a substance that has only carbon and hydrogen. And in an alkene, it usually has one double bond between two carbon atoms. So it has to have one double bond. Alright? And also, alkenes should follow the general formula of an alkene is CnH2n, meaning if you have 5 carbon atoms in the molecule, that means you must have 10 hydrogen atoms. So all you gotta do is look for any one of these structures which has a single carbon-carbon bond. And if you look at it, this is not the case over here, it's not the case over here. Oh, sorry, you have to look for the ones which have a double-double bond, and those will be alkenes. And you don't want the alkenes, so get out the ones with the double-double bond. So this one has a double bond, this one has a double bond, this one has a double bond, and this one has a double bond. So that means that your answer can either be C or F. So the first answer can either be C or F. Any one you choose, it's fine. Alright, the next question is asking you to find which two carbons are isomers. Now an isomer is two molecules with the same formula but different structural formula. So as in C5H10 and C5H10. So these two structures will have the same formula as in this way, but they might be shaped differently, as in they might have the double bond in a different location, or they might be arranged differently in their drawings. So that's what an isomer is. So you just got to look for, in this case, two molecules or hydrocarbon molecules which have the same number of C and H atoms. And if you look at that, it'll be this one, A and B. So A and B should be isomers because they both have the formula of C4H8, right? They both have 8 hydrogen atoms and 4 carbon atoms. But the problem is that the double bond in B, the double bond in B is over here, whereas the double bond in A is at the end. So that means they have different structural formulas. So they're both isomers. Alright, so question 3 is asking you to figure out which structure is propene. Now, to determine the formula for propene, you need to do two things. So first of all, propene has to be split into two halves, ene and the prop. So the ene suggests that it's an alkene, meaning it'll have the general formula CnH2n. Okay? And the propene, the prop, actually, it tells you how many carbon atoms there will be in the thing. So a quick way to know how many carbon atoms there will be is monkeys eat peanut butter. So monkeys, M represents methane, meth, E represents ethane or ethene, P represents prop, and B represents bute. So that means that in this case, prop is the third one. So that means, that means that there must be 3 carbon atoms. So that means that the formula must be C3, and since it's an alkene, it should have twice the number of hydrogen atoms compared to carbon atoms. So C3H6. So you just got to look for the structure which has 3 carbon atoms and 6 hydrogen atoms, and it also has a double bond, a single double bond. And if you look at that, that answer will be E, because it has 3 carbons and 6 hydrogens and then 1 double bond over there, because it's an alkene. Okay, so it says hydrocarbon D forms a polymer. Give the name of this polymer and draw a diagram to represent the structure of the polymer. So hydrocarbon D, look at it over here, and the name of this molecule is actually, it's C2H4, so that means it's ethene. So what happens when polymers occur is that let me just draw this again. is that a polymer is like basically a long chained molecule, and it's used by combining many of these alkenes. So what happens in polymerization is that we'll break one of these CC bonds, meaning each carbon will now have an extra electron, so it can make another bond with something else. So then it can just join to another one of these units, these broken bonded molecules. So that means they'll just keep forming this long structure. For example, in this case, like see, it'll form this long structure, and this can join to another one which is like this, and so on. And this process just goes on until you make these long chain polymers. So what happens with a polymer is that the central one of these bonds must be broken, one of the double bonds, and it needs to extend out. Okay? So I'm doing the diagram bit first. So this needs to extend out, right? So you have two spots for other broken polymers to join. And this is called the repeating unit because it's going to be constantly repeated until it forms long chains. So to draw the polymerized form, you just put a bracket around this and write N. And this just means that N number of repeating units, meaning it'll form a long chain. And that's the structure. And the name of this polymer is actually, whenever you name a polymer, you just say poly, and you just say the name, polyethene. Because poly suggests that there are many, and ethene was the molecule you started off with initially. So it's polyethene, and that's the structure. Alright, so you just got to complete the table to show the relative mass and relative charge of each particle in question 2. So this is pretty simple. When we're talking about relative mass, the neutron has a relative mass of 1. We consider the proton to have the same relative mass, so it's also 1. And the relative charge of any neutron is 0 because it has no charge at all. And electrons are -1 because they're the complete opposite of a proton. And the relative mass of an electron is actually, compared to a proton or neutron, is 1 over 1840, meaning an electron is 1 over 1840 of the mass of a proton. Alright, question 2b, 1 is asking you to use the periodic table to name an element whose atoms contain equal number of protons and neutrons. So I'm just going to quickly show you the periodic table, like how elements are designed. Basically, this number over here is the mass number, and it tells you the number of neutrons and protons. This number over here tells you the number of protons. So this minus this number will actually tell you the number of neutrons. And in this case it's 10, because 20 minus 10 is 10. So all you have to do is, for the first question, find any element where the number of this minus this will be equal to this. And that means that they'll have the equal number of protons and neutrons. And the example which you can use, the answer to this is actually carbon, because carbon has a mass number of 12 and a proton number of 6, so that means that it has 6 neutrons. Next question, you have to find an element that has an electron configuration of 2, 8, 4. Now from your knowledge of atoms, you should know that the number of protons is equal to the number of electrons. Yep, because all atoms are neutral, correct? So all the proton charges must cancel out the negative electron charges. So that means that you just got to find something with, in this case, an electron configuration of 2, 8, 4 means 2 in the first shell, 8 in the second shell, and 4 electrons in the third shell. So that will give you a total amount of electrons of 2 plus 8 plus 4, which is actually 14 electrons. So you just got to find an element which has 14 protons, because since protons equal electrons, that means that that element will have 14 electrons as well. So that element is just silicon, because that has 14 protons, meaning it also has 14 electrons, and that means it'll have an electron configuration of 2, 8, 4. Last question, you have to find the element that has no neutrons. And basically what it means is that the mass number minus the proton number must be equal to 0, because that means that it would have 0 neutrons. And that element is actually hydrogen, because hydrogen has a mass number of 1 and a proton number of 1. So 1 minus 1 gives you 0, meaning 0 neutrons. Alright, so scientists think they would soon make an element that would go directly below acetine in the periodic table. So acetine is in group 7, yeah? Okay, now from your knowledge of groups, yeah, groups is basically the vertical columns in the periodic table. What happens in a group is that all of the elements in the group have the same number of outer shells, the same number of electrons in their outer shell. And also the group number, which is in this case 7, it tells you the number of electrons in the outer shell. So that means if I'm in group 3, the elements in that whole group will all have 3 electrons in the outer shell. In this case, you're in, acetine is in group 7, so something below acetine will also be in the same group, meaning it'll also have the same number of outer electrons. So, and since it's in group 7, that means it'll have 7 outer electrons. Okay? Alright, question 2D shows the diagrams of helium and neon. And they're asking you what is the similarity in the outer shells of these two atoms. Now, remember that in the first shell of any atom, the maximum number of electrons is 2. And in the second shell, the maximum number of electrons is 8. So as you can see over here, you have the maximum number of electrons as you have 8 electrons. And over here, you have the maximum number of electrons as you have 2 electrons. So the similarity should be that both have max number of electrons in outer shell. Meaning they have complete outer shell. Complete outer shell. Alright, question 2D2 is asking you, what effect does this similarity have on chemical reactivity of helium and neon? Now, chemical reactivity is actually caused because electrons are lost or electrons are gained. In this case, both helium and neon have complete outer electrons, so they don't want to gain or lose any electrons. So that means that they will be non-reactive, because if you're not going to lose or gain electrons, you're not going to react with anything. So that means that they'll be unreactive or non-reactive. Alright, so question 3 has shown the reactivity of few metals and they're arranged in order of reactivity. So magnesium is the most reactive and copper is the least reactive. Now, as you guys should know, reactivity determines like what substance will displace another substance. So if I have magnesium chloride, right, and I add a less reactive substance like zinc, zinc is not reactive, so it can't take over magnesium's position. Whereas if I had, for example, copper chloride and I added iron, iron is more reactive than copper chloride, so it would take away copper's position and displace it, and so iron chloride would be formed. Okay, so the same thing applies here. So the first question of 3A says, when zinc is added to magnesium sulfate solution, no reaction occurs. Now why is this? It's just for the reason I just explained, because magnesium is more reactive compared to zinc. So that means that it won't take over the position of magnesium in magnesium sulfate. Okay, so that's the answer. Alright, so 3B1 is saying, when iron fillings are added to copper sulfate, a reaction takes place. You gotta write a chemical equation for this reaction. So I'm hoping you guys know how to write basic chemical equations. So since it's copper 2 sulfate, what happens is it becomes Cu. The valency of sulfate is 2. The valency of copper is 2. And so 2 and 2 cancel, right? And so it becomes CuSO4, because sulfate is SO4, plus iron fillings is just basically iron, which is Fe. And that'll give you, since iron is more reactive compared to copper, iron is going to take over this position of copper, and so it means that it'll form FeSO4, because the valency of iron is 2, plus Cu. And that is your equation. So CuSO4 plus Fe gives FeSO4 plus Cu. Now you got to describe the color changes during this reaction. So you have to describe the color change of the solid. So in this case, you had CuSO4. Now CuSO4 isn't a solid. CuSO4 is actually the solution. And Fe is the solid. Now according to this table, the color of the solid metal is dark gray. So it was originally dark gray at the beginning of the reaction. But at the end of the reaction, Fe combined here, so the dark gray over here disappeared, and Cu was formed, Cu solid, and the color of the Cu solid is pink brown. So from dark gray, it turned to pink brown. Okay, and that's the color change of the solid. Now the color change of the solution, originally you had CuSO4, and over here it says over here the color of the solution in a metal sulfate. So CuSO4 is blue. So from blue, it turned to FeSO4, so this blue color went and FeSO4 was formed. And iron sulfate is green, so from blue it turned to green. So that's the color change of the solution. Alright, so it says when copper is, I'm going to write equations for both of these. So when copper is added to dilute sulfuric acid, H2SO4, no reaction occurs, meaning it just forms Cu plus H2SO4. And when iron is added to sulfuric acid, a reaction occurs and it forms FeSO4 plus H2 because it forms iron sulfate and hydrogen gas. So that means that in this case, in the first case, I'll call this the first case, 1 and 2. So in the first case what happened was that the hydrogen wasn't displaced by copper. But in the second case, the hydrogen was displaced by Fe. So what does that say about the reactivities? That basically says that hydrogen is more I'm just going to recite this. Hydrogen is more reactive compared to copper because copper didn't displace hydrogen, but it's less reactive compared to iron because iron displaced hydrogen from its sulfate solution. Alright, so question 4A1 is just asking you what is the meaning of delta H. What does delta H represent? Delta H is basically just the change in enthalpy of a reaction, and enthalpy is just energy. So it's delta H is just the change in enthalpy of a reaction. Simple. Next, it says what happens to the temperature of the reaction mixture during this reaction. Now before this in 4A they told you that delta H is a negative value. So what do you know about delta H being negative? That would mean that the reaction is actually an exothermic reaction because energy is being lost to the surroundings. Hence the energy of the products is actually lower than the energy of the reactants. So it means that if the delta H value is negative, that means that it's an exothermic reaction, so heat is given out. So what would happen to the temperature of the mixture if heat is given out? By common sense, when heat is given out, the temperature would naturally increase. So it means that the temperature will increase. Okay, so it says hydrogen gas burns in oxygen to produce a colorless liquid. So hydrogen gas burns in oxygen, so plus O2, to produce a colorless liquid. Now, you have H2 and you have O2. What is the simplest liquid you can think of? I'm pretty sure you all know what it is. It's just H2O. So basically the colorless liquid formed is just water. Alright, question 4C is telling you that magnesium sulfate can be prepared using this reaction over here. And you have to tell them how you would make magnesium sulfate crystals using this reaction. Now this is a really commonly asked question, and it's just basically this one process which you can always use. First of all, in order for the reaction to take place, you have to first mix these two substances. And what you do is you add magnesium carbonate to sulfuric acid, so magnesium, just say that I'm going to recite this. So you add magnesium carbonate to sulfuric acid, and then what you do is you add excess of the solid, okay, so that you make sure that all the liquid has been used up. So you add excess of the solid to react with the thing. So you add excess MgCO3. Then what you do is, like any normal reaction, to speed up the reaction, you stir it. So you add it to a beaker, you add both of them to a beaker, excess magnesium carbonate, you stir to mix the whatever, for the reaction to take place. Then what you do is you're going to get this beaker. Now this beaker will have some excess magnesium carbonate because I said we add excess. And what you do is with this is that you take the liquid and you then filter it. You filter it so that you only get that small solution. And what that small solution will be is just basically it'll be MgSO2, MgSO4 and H2O because the carbon dioxide gas will escape. Okay, so what you'll have in that solution is MgSO4 and H2O. So you have this solution of MgSO4 and H2O, but you want the MgSO4 crystals. So you need to get rid of the H2O. So the only way to do that is to just evaporate that solution, right? Because we want to get rid of the H2O. So by evaporating, all of this H2O will go away. Then you'll reach this point where crystals are being formed. Okay? So just before almost all the water is left, right? That's the crystallization point. So crystallization point will be formed. You leave the solution to cool and leave it in an oven. And then only then will the crystals be formed. So in this case, you get a mark for saying excess MgSO3. You have to stir to mix, then you have to say filter, then evaporate, and then you say cool by leaving in an oven. Okay, so you say crystals will be formed, and you have to cool this and leave it in an oven, and the crystal will be formed. So you get 5 marks. Okay, please go on to watch part 2 and comment, rate and subscribe. I know this is my first time trying to teach you guys chemistry, and believe me, it's really hard, but hopefully I'll get better soon. And if you had any questions, I might not have explained the things to the best of my ability, but if you have any questions, just post it down below and I'll be sure to answer them. So thank you guys and see you in the next video.